You ever see a headline or a survey result and just get that feeling, that little voice in your head that says, wait a minute, that just doesn't sound right? Well, today we're giving you a kind of superpower, the ability to see through misleading data. And the secret, the real key, is all about learning to question how that data was gathered in the first place. So, whenever you see a chart or some big statistic, the very first question you should ask yourself is pretty simple. Is this thing telling me the whole truth? Can I actually trust what it's saying? And you know what? The answer, almost every single time, boils down to one critical thing: the method. How did they get this information? Because even a tiny little flaw in how they collect the data can lead to a conclusion that is just massively wrong. And to spot these flaws, we just need to get a few key terms down. First up, we've got sampling methods. Now, this sounds super formal, but all it really means is the ways data is collected. Seriously, that's it. Just think of it like the recipe a researcher uses to get their information. And now, let's meet the main villain of our story today: bias. Bias is what happens when that recipe, that collection method, has a built-in thumb on the scale. It's this tendency to favor one outcome over another, and it can be totally accidental. But it's the number one reason data can become so untrustworthy. And finally, there is graph analysis. This is just how we read the data once it's all put together in a nice chart. But here's the catch. You can have the most beautiful, colorful chart in the world, but it's completely useless if the data behind it is biased. Okay, enough with the definitions. Let's get into it. The absolute best way to learn this stuff is by actually doing it. So we're going to look at a few different scenarios, and your job is to be the detective. Your job is to spot the flaw. You ready? Here we go. First one. A researcher wants to figure out the average population for a state in the US. So they put all 50 states into a hat, basically, and pull out 10 at random. Then they find the average from just that group of 10. So what do you think? Does that sound like a fair way to do it? Is this method biased? If you said no, it's not biased, you are absolutely right. This method is totally fair. And the magic word, the most important word here, is random. Because it was random, every single state, from massive California to tiny Rhode Island, had the exact same equal chance of being picked. That's what makes it a fair sample. Okay, let's try another one. Let's say you want to know the average weight of all the adults in your town. So you think, okay, I'll go to the local gym and just start asking people there. What's your gut feeling on this one? Is that a fair way to get your answer? Is this method biased? Oh yeah, this one is definitely biased. I mean, think about it. The people at a gym are not a snapshot of the whole town, right? They're a specific group who are probably more focused on fitness. The truly unbiased way to do this would be to find a way to take a random sample of everyone who lives in the town. All right, next up. A school wants to find out what students think about a big standardized test. To do this, they only ask the graduating seniors for their opinions. Think about the specific group they decided to ask. Can you spot where the bias is creeping in here? Yep, you got it. This is a classic case of bias by grouping. Seniors, who are literally days away from never having to think about these tests again, might have a very different opinion than, say, freshmen who are just starting out. To get a real fair picture, you'd have to ask students from all the different grade levels. Okay, here's one straight from the world of science. Researchers are testing a new drug, so they get a bunch of volunteers, split them into two groups, and then, at random, they give one group the real drug and the other group a fake sugar pill, a placebo. Now, this one might seem a little more complicated, but just follow the logic we've been using. Is this a biased way to test a new drug? And the answer is no. It's not biased at all. In fact, this is the gold standard for how to do good, clean research. And there's that magic word again, random. By randomly assigning people, researchers take their own opinions and hopes out of the equation. It's a really clever way to make sure the results are as accurate as they can possibly be. Okay, last one for you. An ice cream company wants to predict how much money they'll make for the entire year. To do this, they only look at their sales numbers from the month of December. Come on, think about this one. Ice cream and the month of December. Does that sound like a fair way to predict sales for the whole year? Of course not. That is super biased. For most of us, December is cold. It's hardly peak ice cream season. Their prediction would be way off. To fix it, they'd need to take a random sample of months from throughout the whole year to get a real, accurate picture. So, why does any of this matter? Well, because spotting bias isn't just a fun little brain teaser, it's a really critical life skill. It's how good teachers figure out which teaching methods actually work. It's how doctors choose treatments that save lives. It's how engineers design bridges and cars that keep us safe. From stockbrokers to insurance agents, getting the data right saves time, it saves money, and sometimes it really can make all the difference. So, if you only remember one thing from all of this, let it be this. The whole point, the secret to all of this, is that good, unbiased sampling means every single person or thing you're studying has an equal chance of being picked. That's it. That's the core idea. So now you have the tool. You know the big question you need to ask. As you go through your week, scrolling through the news or social media, I'll just leave you with this one last thought. What data will you question tomorrow?